Hello, welcome. Let's try to solve a Leetcode problem 207 course schedule. First of all, let's try to understand what is the problem. And so for this problem, I will give a detailed explanation of what is a topological sort and why we can use a topological sort to solve such problem. So let's try to first understand the problem. We have a total number of numbered courses, so this means we have two courses, right? And these two courses we have to take. This means we have to finish these two courses. So the course label is labeled from 0 to n-1, so course minus 1. It means the course label gonna be 0 and 1 if there are only two courses. So we are giving an array of prerequisites. So the prerequisites have some meaning. So what's the meaning? It means prerequisite I. So for example, prerequisite I is a tuple with AI and BI. So for example, this is 1 and 0. Indicates that you must take course B first if you want to take course A. So this means inside this array, if you were to finish course 1, you have to finish course. If you were to finish course 0. Let me just use it here. So for this example, for 0 and 1, if you were to take course 0, you have to finish course 1 first, right? And for this example, if you want to finish course 1, you have to finish course 0 first. This is just confusing. Let's just use a tuple of A and B. Just explain what's the meaning. So this means we have two courses inside a tuple with A and B. If we want to finish course A, we have to finish course B first. And let's just make a drawing, and it can help us to understand the problem. So this is gonna be course A, and this is gonna be course B. So if we want to finish course A, we have to finish course B first. So how to make the drawing? We're gonna make a topological structure with this kind of drawing. So B will point it to A, so it's gonna be a directed graph. So inside of this graph, it means currently we can finish course B because there's no course pointed to B. There's nothing. So this means for my integrate of B is 0. So for me, it is okay. I can finish B. But in order to finish course A, I have to finish course B first. You can see that this is like a topological structure. So this is why we can use the topological sort to solve the problem. Topological sort is not like merge sort or quick sort. It is not like a sorting algorithm. Topological sort is just a structure. It is a topological structure, and we're going to use the topological structure to solve the problem. And what is a topological structure? As you can see that this B pointed to A, and there's no loop, and there's no cycle, no circle, so this is like a topological structure. So if we have a course like ABC, like this kind of a structure, so in order to finish course A, we have to finish course B. In order to finish course B, we have to finish course C. So in order to finish course C, we have to finish course A. As you can see, this is going to be a loop. So this means they are independent with each other for each of the course. It means we can never finish all the courses. Maybe we can only finish one course, but we cannot because it is totally a loop, because they are independent with each other. So in this kind of structure, we can finish 0 course. It means we can never finish a course. But in this structure, it is a topological structure. It means we can finish all the courses. But where will we start? We're going to start with the course with the integrate with 0. So for this node B, the integrate is 0. For this node A, the integrate is 1. But how can we loop through the graph to solve the problem? We're going to use the BFS. Definitely there are two ways to solve the problem by using topological sort. So one is the DFS, one is BFS. But the easiest way is to use BFS because BFS uses the iterative solution. It is very clear. So like from here, we're gonna start from the node B, and while we finish the node B, this means this course is finished. And then for node A, because this course is finished, so integrate before it is 1, it is going to minus 1, so integrate going to become 0. If the integrate is 0, it means this course can also be finished. So we're going to put it inside of the queue, and then we're going to check it. So if there are some other courses, we can still check it. Maybe this is a C, maybe there is another course, this is a B, B is also ported to C. Yeah, so this means we can, I'm sorry, this gonna be cos D. Let's just make it cos D. It should be clear because this is cos B. Yeah, so we're gonna make a cos D. Yeah, so cos D gonna be finished first, cos B gonna finish first. Yeah, and then cos A gonna be finished. If this is finished and this D also finished, this means cos C can also be finished. But how can we check? We're gonna use the integrate to check. If the integrate is 0, we can always finish this cos. Yeah. So if you understand about the topological sort and in which condition we can use it, normally you can solve it. And why we can use it to solve cost schedule problem? Because cost schedule is always have some independent with each other. Because they will always design a topological structure for the cost schedule. If they design a structure like this, they are independent with each other and there's a loop. It means it is a wrong design of the cost schedule. If they design it rightly, definitely we can use the topological sort to solve the problem. Because definitely they depended on each other, but there's no loop. Yeah, and we can finish this cost and then finish others. Yeah. Now let's try to solve it by using BFS. So for the topological BFS structure, definitely we're gonna use a graph and we're gonna use an integrate. So the graph is gonna be an adjacency list. So in Python we can use the default dict, and inside I'm gonna have a list. And for the integrate, I'm gonna prepare an integrate array. It means for each of the node, what is the integrate for each of the node? So I'm gonna need to times the number of courses. So this means for index 0. This means for node 0, my integrate is 0 from the beginning. For node 1, my integrate is also 0 from the beginning. So this is just the preparation. And then I'm gonna loop through the prerequisites because this is used to build the graph and build the integrate. So I'm gonna check with two courses, a tuple A and B, inside the prerequisites. Now I have two courses. I need to build a directed graph. Because the course is dependent on each other, and this is a directed graph. Because if I were to finish this course 1, I have to finish course 0. Yeah, and similarly for here, if I were to finish course A, I have to finish course B first. Yeah, so this means for the graph, it means graph with B should append A. Yeah, so this means I'm gonna start from this node B, and then I will go to node A. Yeah, so this is why we can use this kind of a way to build the adjacency list. And similarly for the integrate, because B gonna be ported to A. From the beginning, the integrate of B gonna be 0, but the integrate of A, because there is a node ported to it, so it's gonna plus equal to 1. Yeah, so currently we've already built the adjacency list and the integrate. Let's just check what is inside. Yeah, let's just check what is inside to prove everything should be okay. Let me just return a 0. Yeah, let's just check the example 1. So for the example 1, we have an adjacency list. Yeah, so this means the node 0 gonna be ported to node 1. So this is okay. We're gonna finish course 0 first, then we're gonna finish course 1. And for the integrate, it is also the same. For node 0, the integrate is 0, so this means we're gonna start from this node 0, because if it is 0, we can always start with the value which is 0. Yeah, because for node 1, the value is 1. It means there's one course. It depended on one course. We cannot start this course. But if this is 0, it means there's no dependency. We can start this course with label 0. Yeah. So if we understand it from here, normally it's gonna be easy for us to use the BFS to solve it. So for using the BFS, we need a double-added queue. So I'm gonna use a queue, and I also need to have a result. This result gonna be count the number of courses I can finish. So for the queue, I'm gonna prepare a dequeue, and inside I'm gonna prepare an array. Yeah, because definitely I need to put some nodes inside the queue. But currently, what kind of nodes can I put it inside the queue? I can always put the node, which is the integrate. I'm gonna check the integrate. If the integrate is 0, definitely I can put it inside the queue. So I'm gonna check it. So integrate I. So for I, V, enumerate the integer. I'm gonna check if this if the integer, if the number equal to 0, and I can put the label, the node, inside my queue. And for the result, from the beginning, it is just a counter. I'm gonna put it as 0. And now I can check the queue. So while queue, I'm gonna pop out the node. So node gonna be equal to queue.popLeft. Yeah. So we're gonna pop out this node. Yeah. So normally I would like to keep the consistent with the topological sort structure and queue structure. I'm always pop to the left, pop from the left. Yeah. So I pop from the left side and I get a node. And I want to check the neighbors. So for neighbor inside my graph, I'm gonna use this graph. Yeah. I want to check all its neighbors. So for the neighbors, I want to check the integers first. Yeah. So if I find a neighbor, this means my integer for this neighbor gonna be decreased. Yeah, because for example, let me use this drawing like here. This is a cos A and this is a cos B. Because cos B pointed to cos A, directed it to cos A. This means currently I'm going to check this node B, cos B. If I finish this cos B, I'm gonna check its neighbors. So my neighbor gonna be cos A. Yeah. So currently I check cos B. It means I can finish cos B. So if I can finish cos B, it means the integer of cos A gonna minus 1. So this is why here integer neighbor gonna minus 1. So let's just try to check if the integer neighbor gonna minus 1. Yeah. If it minus 1, it might be possible the integer with this neighbor gonna become 0. If it becomes 0, the strange things are gonna happen. Yeah, so the interesting thing happens. So if there's another node, maybe this is a node C. If this node is 0, it means there's no dependencies. We can finish this cos already finished, the cos B, and for cos A, no dependencies. We can also finish it. Yeah. So this is why we're gonna check the neighbor if it is 0. So if it is 0, it means this cos can be finished. So if it can be finished, definitely we want to put it inside the queue, because we want to go forward to check the other causes. So we're gonna put the neighbor inside the queue. Yeah. So currently we've already finished the structure of the topological sort by using BFS. It is also called Kahn's algorithm. Yeah. And now what we need to do is to solve the problem. So we're gonna return true if we can finish all courses. But currently we didn't count how many courses we finished. So it is also easy. So this means if we pop out a node, definitely we finished one course. So the result would plus equal to 1. And finally, we just need to check the result if it is equal to the number of courses. If it is equal, it means we can finish all courses. Otherwise, so we're gonna return a false. Yeah. So this is the total structure of the topological sort by using BFS. It is also called Kahn's algorithm. First of all, we need to find the topological structure, and then we're gonna use the topological structure. We're gonna design a BFS to solve the problem. Now let me just run it to check. For neighbor, it should be inside the node, right? Yeah. So because we pop out to the node, we're gonna check the neighbor of the node. Definitely, it is a node. I made a mistake. Now, as you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed, and it's pretty fast. Now let's analyze the time complexity. First of all, let's check the for loop from the prerequisites. So this is ON. N is the length of the prerequisites. It is 5,000. Up to now, it is okay. Up to here, it is also okay because we are checking the integer. Integer depended on the number of nodes. So currently, it is ON plus N. It is okay. Now we are going to use the BFS to check. Basically, this is a topological graph structure. And for the graph, we're gonna check the number of the courses. It means the number of the nodes and the number of the edges. It is the prerequisites. So the time complexity gonna be let me make a drawing to check. So basically the time complexity, it is like traverse BFS. Maybe there are some nodes, but this is the nodes, and this is the dependencies, and the time complexity gonna be m plus n. Yeah, because for the adjacency list, basically we're gonna need to traverse through each of the node, and for each of the node there's neighbors. It means how many edges. So this is the prerequisites, this is the edge, and this is the vertices. So basically it is the edge plus the vertices, and this is going to be the time complexity for such algorithm. Yeah, so for example, first of all you're gonna pop out this node, and then you put its neighbors, and its neighbors depended on how many edges, and then you're gonna put the node and check its neighbors. Yeah, so this is gonna be m plus n for the time complexity. Thank you for watching. See you next time.